Today's lecture is going to mostly take the form of a meditation with some math, which will involve just, a little bit of practice with 2D functions and their derivatives or partial derivatives, which are, related to limits and continuity. That's about the most, because in the previous weeks, we introduced partial derivatives and, multi-dimensional definitions of all these functions and continuity, but you really can't understand it until you apply it to some actual problems. 今天的讲座会以静坐的形式进行，当然也会有一些数学，因为我们会就是真正的去实践我们前几次讲的二维方程的导数偏导数或者偏微分，然后这些也都包含极限和连续性的概念，因为二维和多维，你光去听和知道不够，你还得实践才能懂。Okay, so first of all, think about this. Two questions. What has no opposite? What is the intersection of all paths? 首先，想一想这个。第一个问题，什么没有相反？第二个问题，什么是所有道路的交叉？Okay. So by intersection of all paths, you might think about maybe the source of all paths or the destination of all paths. 比如说所有道路的交叉点你可以想一想那什么是所有道路的起源，什么是所有道路的去往的地方。Okay. On to the math. Let's find 2D derivatives. Okay, so suppose f of xy equals x squared minus y squared. This is called the monkey saddle. It's a very famous function, and you should definitely learn what it looks like and how to draw it. So, multivariable calculus is very visual and kind of artistic in that at least learning how to draw, not super aesthetically, but at least being able to draw mathematically correct 3D drawings is super useful. So let's say this is the x-axis, the y-axis, and the z-axis, okay? And one way you could draw this is just, look at x squared. Okay, so suppose that y is a constant. Let's say y equals 0. then f of xy equals x squared. So when y is 0, so that's anywhere along this line up and down, so this plane, then z equals x squared. So by f of xy, I mean z, okay? And that's easy to plot. Something like that. And then what if, y equals 1? Then we get z equals x squared minus 1. Well, y equals 1 means that now you move a little farther this way, okay? And then you take all the x and z values at that y value. And so it's going to lie somewhere in that plane. And yeah, it's just going to be another parabola, but slightly lower down. And basically, you're just going to take this and copy it. But every time you copy it along that direction, you lower it down. And similarly, same thing in this direction. Okay, what about if we ignore x? Then, like if x equals 0, that would mean going along the x, we go to x equals 0. And then we can be anywhere in the yz plane. And z will be over there, negative y squared. So that's easy to plot as well. It's just this. Whoops. I have a handy dandy erasable pen. Okay. Yeah, and this will just copy itself as well, going up like that. There's a copy there, and there's a copy here. Okay, and then you just connect everything together roughly. Okay. Yeah, so that's a monkey saddle. It does look like a saddle, doesn't it? You can yeah. Okay. 咱们先计算一些二维导数或者微分。忘记这个，可能是这个数。假如我们的方程是f of x 与 y 等于 x 平方减 y 平方。它这是一个很著名的方程。你应该学会怎么画它的图。它是长什么模样的？它叫monkey saddle， 就是给猴子骑马的座位。这真的是可以放在马上，然后一个猴子可以坐在上头骑着马 ，right? OK， 骑马的座位，monkey saddle，OK， 不知道中文怎么说。然后我们怎么去画它的图？就是这个多维微积分，它是比较艺术性的，因为能够画三维图，也不必要画的特别美，但至少要画的是按照数学来说是对的图，是非常有用的，而且你应该学会怎么画三维图，所以我们怎么画它呢？我们有一个 x 轴，一个 y 轴，还有一个 z 轴， 这个 z 它就是 f 的值，所以我们的方程就是 z 等于 x 平方减 y 平方。然后我们可以先忽略 y， 比如我们看 y 等于某个数的时候，y 等于0的时候，这个方程就是 z 等于 x 平方。y 等于0的时候，那就是在 y 轴上，必须得在这个点。但我们在 x 轴上和 z 轴上可以在任何一点，所以那就是在 x z 平面上画的图，就应该画 z 等于 x 平方，那就是这个图。然后我们再说，那 y 等于1的时候怎么画呢？ y 等于1，那就是往这边走一会儿，然后在这个位置的 xz 平面上画一个图，那就是z 等于 x 平方减1，也就是这个图，但稍微把它往低一点挪，然后我们要是继续这样的话，我们就会一直往这个方向把它拷贝而挪得越来越低，然后同样往这个方向也是，就是不停的拷贝，不停的往越来越低挪。然后接下来我们可以看一看x 等于某个数值的时候，比如 x 等于0的时候 z 等于负 y 平方。那 x 等于0的时候，那就是在 x 轴上的这个位置，然后我们就在 yz 平面上画 z 等于负 y 平方的图，然后我们再把它拷贝和挪，拷贝和挪，那就是画这个图，还有画这个图，然后我们可以把这些都连起来，这就是x 平方减 y 平方的图。Okay, so let's calculate what is partial f partial x as defined in my previous lectures. Then you just take partial x of x squared minus y squared. And you just treat the y as a constant, so it's like x squared minus some number, okay? And then we know how to take the derivative with respect to x of that, 2x. Okay. Now, let's ask, is it continuous? But obviously we want to know, like, where is it continuous at? Like, continuous everywhere, continuous at this point, continuous at this point. Let's say, is it continuous at the origin? 0, 0, 0. Or sorry, not 0, 0, 0. It's just a... Is it continuous at xy equals 0, 0? But of course, z is also equal to 0, so we could just say, is it continuous at 0, 0, 0? Sure. Now remember, as I defined previously, for a 2D function to be continuous, or 3D, whatever you call it, it's a function of two variables, I'll call it a 2D function, then it has to be continuous at that point when you take the limit along all paths. So let's say, like, we want to take the limit as h approaches 0 of f of x plus h comma y minus f of xy all divided by h. So does that, like, remember it has to exist and function exists in this case, the function is 2x. Okay, and then they have to equal. Okay. So let's try, along the path, just y equals 0. So then that would mean the limit as h approaches 0 and when y equals 0. So along the path y equals 0 means that, here's y. We're going to go along this way and find the limit of the partial derivative of f. Okay. Well, then you just plug in 2x, and when y equals 0, that equals still 2x. Now let's calculate along the path y equals x. So, okay, this is partial f, partial x, along y equals 0. And it's also like, and it's actually it's actually taking a limit as h approaches 0 and y equals 0. So they both equal 2x. Okay, and then along the path y equals x, do we get the same 2x? Well, now we take same thing, but 2x, and plug in y equals x. And yeah, it's still 2x. And in fact, along any path, y equals f of x. Okay, so this is along this path. Okay, and then for y equals f of x, we take the derivative along some, I don't know, whatever path towards there. Y versus x, okay? And no matter what y equals, 2x is always going to equal 2x, which equals 0. So yeah, it is continuous. So yeah, we just did, this is problem 1 and problem 2. Great. OK, 咱们来计算2个题目。第一个题目就是partial f partial x， 就是 f 对 x 的偏微分或者偏导数等于什么？那就是f 就是 x 平方减 y 平方，然后对 x 的偏导数。这个我在之前已经定义过偏导数，所以我们就是把这个 y 忽略，把它那个对待如一个常数，所以我们就是在求 x 平方减某个常数的对 x 的导数。我们知道怎么求这个，这就是 2x。OK， 然后第二个问题，这个 partial f partial x 2x 它是否连续？那连续我们总得说它是在哪儿连续？ 它是在所有点连续吗？它是在这个点连续吗？它是在那个点连续吗？咱们就对待它是否在这个点，也就是 x y 等于0，也就是 x y z 都等于0的时候，它是否连续 ？OK， 那怎么？我定义过，就是二维方程要是想连续在某一个点连续，它必须求那个极限随着任意道路往那个点求极限就是顺着任何路径，结果都就是它应该都是连续。所以也就是说，我们那个用这个导数的极限定义，极限 h 趋于0 ，OK，f(x) 加 h(y) 减 f(x, y) 除以 h，然后我们需要满足这个极限存在，还有那个函数。这次这个函数就是 Rx 也存在，然后它们是相同的，才说明连续这个函数连续。而且我们选任意路径，比如我们可以随着 y 等于0的路径求这个极限。那也就是说，我们把所有这些 y 以0代替，也就是说，我们求 Rx， 然后把 y等于0，那 Rx 就是它这边没有依赖于 y， 所以它仍然是 Rx。然后我们可以再试一试，那随着 y 等于 x 求极限，那就是 Rx， 然后把所有的 y 以 x 代替，它仍然等于 Rx。所以而且就是满足这些条件。那要么随着任意路径，比如可以长得像这样子，或者根本不一定连续性的路径。那 Rx然后把所有的 y 以 f(x) 代替，它仍然等于 Rx， 所以这才证明了是的，这个 f 的 x 对 x 的偏导数是在这个点连续。OK， 咱们有时间再做一道题。OK， 有点没有地方。Okay, so let's do another one. Y or f of x, y equals absolute value of x minus absolute value of y. OK， 这次咱们试一试f 等于 x 的绝对值减 y 的绝对值。To graph this, we use the same method. We should get something like this. Okay. It's similar to the monkey saddle. Okay, we can start by graphing that part and that part. Okay. And then copy some things. Something like that. Okay. Okay. 差不多长这个样子。这个，yeah. OK， 所以我们用同样的方法去画这个方程的图。 然后我们就先画当 y 等于0，当 x 等于0，再拷贝这个，然后把它连起来。OK， 差不多是这个样子。Now let's try to find partial f. So it looks similar to the previous function, except that it's more jagged. 所以它长得很像之前，只不过是它更不那么柔软。OK， 更尖 ，yeah. So what's partial f partial x? Well, that's gonna equal partial x of absolute value of x, which is going to equal 1 if x is greater than 0 and negative 1 if x is less than 0, and if x is equal to 0, we don't know. It's both, huh? So here's x, okay? And when x is greater than 0, then the function is here, and it's got slope of 1. But when x is less than 0, it's got a slope of negative 1, or a partial derivative of negative 1. And when x equals 0, is it 1? Or is partial f of x equal to 1? Or is partial f of x equal, partial x equal to negative 1? So it's not continuous. Okay. OK， 所以我们要是再求那个 f 对 x 的偏导数，那就是绝对值 x 的偏导数，也就是当 x 大于0的时候等于1 ，x 小于0的时候等于负1 ，x 等于0的时候不知道它到底是1还是负1，还是同时两个都是。咱们看一看这边，x 大于0的时候，我们的方程 f 等于这个，x 大于0的时候，它的对 x 的偏导数等于1 ；x 小于0的时候，偏导数等于负1 ；x 等于0的时候，从这个方向等于1，从这个方向等于负1，所以我们也可以说partial f partial x 就是 f 对 x 的偏导数，这不是连续性的，因为它在某一个点不连续。Okay. That's all for the math. Okay, so let's go back to our question. What is the intersection of all paths? Because as we have seen, at least for derivatives, depending on what path you're going along, then you might not have a continuous value of a derivative. Okay. 所以咱们再回到我们的问题，什么是所有道路的交叉？因为我们从数学的观点来看，就是我们发现到了不同的路径道路，某一个比如偏导数，它可能会不存在一个值，比如就是这个 partial f partial x， 它不一定存在有一个连续的值。So to summarize, a 2D limit can be multiple values. Just along different paths. 总而言之，任何二维级数，不是 可有多个值，只不过，沿着不同道路。OK，那其实所有的物理东西，OK， 物体，据薛定谔猫来形式，也都可以有，同时是两个值。Oh my gosh. So actually, every like physical material can also be multi-valued, like two different states at the same time, according to Schrodinger's cat, or the metaphor of Schrodinger's cat, which basically comes from quantum physics. Okay, we have Schrodinger's equation. Which is that, the state, for example, energy of a system, such as an electron, is actually a probability wave function. It's a probability wave. Okay, and it's somewhere between, like 0 and 1, or -1 and 1, with some probability. OK， 这个告诉我们，就是用薛定谔方程，它是描述一个系统，的状态。比如这个系统可能是一个电子，它的状态，比如是它的能量。OK， 而这个状态等于一个概率波。这个我可能写错了。OK， 概率波。也就是说，它是0和1之间，或者-1和1之间的某一个值，但我们只知道它每个值都有一个概率。So then one can ask, well, what if, like, why not, and also this is really useful in everyday life because the world is becoming more and more quantum, and it's, the world, everything is made of these, two states at once, Schrodinger's cats, or, that are both alive and dead, both 0 and 1 at once. 这个非常有用，因为我们的世界本来就是以这个组成的，就是同时一切都是同时不同值 就像说林格猫，它同时是死的和活的，同时是0和1。而且我们平时经历的世界也越来越量子性了。Well, then why not go all the way to multiple dimensions? Like, so this is 2 paths. What about the intersection of infinitely many paths? 那要是我们把它提高到更多维的话，就是说林格猫它是2个道路的交叉点。那要是无穷道路的交叉点是什么呢？那我们就到了一个非二元性。而且是非OK， 就是无穷维的非二元性。So that takes us to non-duality, except that it's an infinite dimensional non-duality. And now we get to meditation. So think about like all the things that have an opposite. Like, you know, black versus white, right versus wrong, good versus evil, happy versus sad. And then you could get even more spiritual and, you know, into like attachment versus non-attachment, good versus bad, non-duality versus duality. Everything has an opposite. What has no opposite though? Like it's not something that we can define using words. But we can describe it. I mean, it has no opposite, which means that it can't be described in words. Because you could always say, you know, if you describe it as blah, then there's going to be the opposite of blah, or non-blah. It must be the intersection of all paths. It must contain all of us. We must all contain it. It must be in all of us. OK， 所以我们现在到了静坐模式。什么没有二元或者相反？咱们想一想，所有的有相反的东西有黑就有白，有好就有坏，有上就有下，有快乐就有悲伤。要是更灵修性的话，就是有牵挂就有非牵挂，或者有非牵挂就有牵挂。有二元性就有非二元性，所以它是不可以用语言来定义的，任何语言，但可以用语言去描述，它是没有相反，所以它是不可以以语言定义的。那说明它应该是包含我们所有，就是所有路径的交叉点，然后我们所有都包含它就在我们所有之内。So it's kind of like a state of mind, an experience. And this is going from what I call ND problems require n plus 1D solutions. Because as long as you keep in the state of mind of good versus evil, you're never going to solve the problems of evil. It will always exist as long as good always exists. Unless you go beyond the whole dimension of duality, only there evil does not exist. And you might have noticed that all of my lectures have been going from, ND to n plus 1D. We went from like limits and non-attachment to now non-duality and so on and so forth. But I also want to just point out something mathematically useful, which is, these continuous partial derivatives, okay? They are useful for something called the controlled convergence theorem. Which tells us when can we do partial x of the integral of f of x, y, dy equals the integral of, from like y goes from a to b. So then this would be derivative. So yeah, this is basically telling us when can we do derivative of the integral equals the integral of the partial derivative. And you can find, well, there's only two places where I have seen it written. One is in this book. It's called the Lebesgue Controlled Convergence Theorem. And this book is linked on my website, themathematicianisin.wiki.com. And you definitely want to see both the book, which is actually, its PDF is for free on the author's website. But you also want to see its errata, which is also on the author's website because it has a lot of errors, all right? And then there's also another place, which is online at Stack Exchange. Will moving differentiation from inside to outside change the result? That's the question. And is the answer about like 12 years ago? Yeah. By my classmate from college. And that's the same thing as the book says. But as for the proof, it's in the German and French Wikipedias. Or else learn some applied analysis and then you'll learn how to prove it. Okay, 所以我们 你可能会发现到就是只要是存在好和坏就永远解决不了坏，因为只要是有好就有坏。所以我经常说 n 维的问题需要 n 加1维的解决才能真正的解决。你可能会发现到我的讲座，他们其实都是在从 n 维到 n 加1维，从之前讲过极限与牵挂，然后到现在非二元性，再继续，所以，这个非二元性或者无穷维的非二元性，它更是一种，境界，或者一种维度，就是超越之前的维度的境界，或者一种经验。希望经常处于那个境界。然后我也刚想起了这个偏微分偏导数的连续性，它有一个很重要的应用，这就是 Lebesgue controlled convergence 定理，就是控制收敛定理吧。控制收敛，我忘记怎么写了，收敛定理。OK，我发现这个定理它只在2个地方写下来的，一个地方是math.stackexchange.com/questions/12909。Will moving differentiation from inside to outside an integral change the result? OK， 一个就是这个网站，怎么模糊了？把它擦一擦。这也太模糊了吧 ！Oh my god！OK，、也就是在这儿，他是12年前被我的同学回答过，但那些证明定理的证明，他们都在那个德语和法语的维基百科，或者第2个地方就是在这个课本里头。它叫 Lebesgue controlled convergence theorem，这个课本也在我的网站上，然后你就找那个课本，但它的链接在那儿，它是在网上免费的，在那个作者的网站上公开的，他也在网上也放了他的那个 errata， 就是所有的那些错误和改变，也都在他的网站上。你一定也要注意到那些，因为这本书它有很多错误。OK， 然后你也可以学叫什么泛函分析就能够证明这个定理。它就是告诉我们什么时候积分的导数等于偏导数的积分。Okay, that's all. Bye bye.